Hello and welcome to this Embarcadero Developer Skill Sprint, a guide for practical usage of RTTI Attributes. I am Rodrigo Ruz, Senior Software Developer and Embarcadero MVP. There is my Twitter and GitHub accounts where you can reach me. Also, in the blog notes section you can find the links, the source code, and a replay of this skill sprint. This skill sprint works on Windows, OS X, Android, iOS, RAD Studio, Add Method, and Objects Pascal. The next presentation requires a previous understanding of the Delphi runtime type information. C++ Builder will be not covered on this skill sprint because it doesn't support Delphi style RTTI attributes. So you can find more information about the C++ Builder and the Delphi RTTI support in the Embarcadero doc wiki. On this skill sprint, we will cover a brief introduction to what are and how work the RTTI attributes. Then we will see how the RTTI attributes can be used to change the behavior of our objects. Finally, we build an application that uses attributes to validate and transform the members of some classes, only decorating with attributes and without modifying the source code at all. Okay, so what are the attributes? The attributes are a Delphi language feature that allow you annotate types and type members with metadata that carry additional information. To create a custom attribute, you must declare a class which derives from the custom attribute class. And of course, how any class, an attribute can contain properties, fields, custom constructor, and so on. This is an example of a declaration of a custom attribute class. In this case, this attribute will be used for validate the members of an object. As you can see, this class called validation attribute have an overloaded constructor and some additional methods and properties. The custom constructor have a parameter which defines the default action to be used if the validation fails. The validated function implements a custom validation code. The custom message property returns the message to be shown if the validation fails. Finally, the validation action property returns what kind of action must be executed if the validation return false. It's very important to note which, when you define an attribute, all the values passed to the constructor must be constant expression because all those values are embedded directly into the final binary. So you can use expression or values that require runtime evaluation. You can use constant expression like set, strings, ordinal expressions. You can use the type info method to pass type information because the RTTI address are now in compile time, and you can use class reference too. But you can't use out of our parameters because they require runtime evaluation of the address of the passed parameter. Also, you can use the address function or the h operator. In short, you can use any expression which require runtime evaluation to determine its value. The attributes can be used to decorate several elements as classes, fields, properties, nested types, methods. Even the arguments of the function and procedure can be annotated with attributes, how is shown in this class. After you define your attributes and annotate your types, you need to determine which attributes are present in a given type. So in order to inspect the attributes, you will use the getAttributes method. The getAttributes function returns an array of the attributes associated to a given type. This function exists in all the RTTI object descendants. This chart shows every RTTI object which support the getAttributes method. This is a basic snippet which shows you how to inspect the attributes associated to a given type. First, we extract the type information for the tfoo type using the getType function. Then retrieve the custom attributes using the getAttributes method of the RTTI type. And then check the class type of the current attributes and do some custom processing. The attributes are useful when you want to introduce a new behavior to type such objects or records. Probably you are saw some samples of how you can use the RTTI attribute to persist object to ini and XML files, login objects. Attributes are useful to test frameworks, bin property to database fields, and so on. On this skill sprint, we will talk about how you can use the RTDA and the custom attributes to perform some actions like validate and transform the members of a structured type such object based on his attributes. This task will be done by creating some simple but specialized attributes for runtime validation and transformation of objects. With this approach, you only need to decorate your object with the RTTI attribute without modifying the implementation of your objects. Okay, so now we will check some source code to see how you can use the RTTI attributes to validate and transform the properties of some classes. Okay, this is a simple console application with a tsettings class. This is a very basic object used to save some database connection data to a file using the JSON format. How you can see there is a server property used to store the address of a remote machine, a port property, a database name, user, password, and some functions to load and save the settings. Now, what we'll do next is validate the property values of this class before to save it, only using RTTA attribute. So I will start to create a new instance of the class. Now I will create a new unit to define the attribute used to validate the class member. I will call this unit uValidation, and I will create a basic custom attribute. We will call to this class validation attribute. This class descends from the tcustom attribute class, and this will be the basic object for all our validation RTTA attributes. This class contains a function to perform a validation of a class member and a method to return a message when the validation returns false. Next, I will define an attribute called mandatory, and I will override the validate and the get custom message functions. The get custom message will say this member is empty, and the validate method will return false if the value of the property is an empty string. Now I will return to the tsetting class, and I will annotate the server property with the attribute called mandatory. And until now, only we define the attribute, but no validation is performed yet. We need to create a method to iterate over the members of the class and check for the associated attribute. This function will run the proper validation for each attribute defined, and I will call to this method tryValidate object. This function receives two parameters, a class instance and a tstring list to store the message returned by the attribute. Next, I will add some RTTA objects to iterate over the class to validate. Defining a trtda context record to access to the type information, and some additional elements to hold the type info of the attribute and properties. Now, in order to inspect the current object, we need to extract the type information of the class using the getType function. Then we need to iterate over the properties of the class using the getProperties method. Next, I will get the attributes of the current property with the getAttribute function. Then we must check if the type of the current attribute is a validation attribute class, because the property can have another attribute associated. Next, I will execute the validation in the property. We do this casting the current attribute to the validation attribute type and calling the validate function. If the validation returns false, we'll set the result of the try-validate object function. Now we set up a nice and informative message with information about the property and the attribute where the validation fails. And we add the message of the attribute to the string list. So the try-validate object function. As you can know, this method only is checking the properties of the class, so you must extend this function if you want to add support to fields or another members of the class. Now we need to call this function in order to run the validations. I will modify the code to show the content of the tSettings class using some JSON functions to format and show the content of the object. Now I will run the application. And this is the content of the tSettings class. Now I will call the try-validate object function, passing the current instance of the tSettings object, and depending on the result, I will show a custom message. Now I will run the application. This is the result, and the message says the validation failed. So the validation returned false because the server property is empty. Now I will set a value for the server property, and I will run the validation again. Now I will run the application to check the result, and now the result says the validation passed. Now I will to replace the message for when the validation fails, because now it's not giving much information. So I will add a string list and his reference to the try-validate object function, and I will set the server property value to an empty string. Okay, running the application again. Now we obtain a much better and descriptive message, which says the name of the validation that fails and in what property. And now I will annotate another properties with the same attribute. I will add to the database name, the user and password properties the same attribute. I will run the application again. And now you can see a text for each property which failed the validation. On this case, the server, database name, user, and password. Now we will set a valid value for the server property, and I will run the application. And the server property is not listed in the result of the validation because have a valid value. Until now we are using only one attribute for each property, so we will create another one for the server property. This attribute will validate which the current value is a valid IP address, so I will copy the same definition of the mandatory attribute, and I will be called IP address attribute. Now I will set up a message to be returned if the IP address is not valid, and the validation will perform regular expression, so I will add the regular expression unit, and I will use the isMatch method of the regular expression object, passing the current value of the property and a string representing the regular expression that will be evaluated. So now for test the validation, I will annotate the server property with the IP address attribute. I will keep the value of the server property to test the validation, but I will set up the values for the another properties, the database name, user, and the password, and I will run the application. And you can read the message which the validation fails on the server property because it's not a valid IP address. But if I replace the server property with a valid IP address and then run again, the validation pass. So far we are created only attribute without parameters. So now I will define a new attribute for the port property in order to validate a valid range of the port. So I will go to the interface of the unit and I will copy the same definition of the IP address attribute, and I will name to the new class range attribute. Now I will add two additional fields to store minimal and max value of the range, and also I add a custom constructor which receives the two parameters with the range values. Now in the constructor implementation, I will call the original constructor and assign the range values to the fields. Then I set up a custom message for the attribute. I set the value of the result for the valid function, depending of the value of the current. And now I will annotate the port property with the range attribute. Then I will run the application to test the new attribute. And the validation fails with the message indicating which property value is out of the allowed range. So this is correct because the value of the port property is 0. So now I will set up a valid value on this property. Now I will run again the application, and you can check how the validation passed. Okay, now I will return to the attributes code. How you can see the t-value used in the validate method is using the hasString function to compare the value of the property against an empty string. This code only will work with the string property because if you assign the mandatory attribute to a property of another type, an exception will be raised. This because some type can be casted to a string. So in order to fix this, you can check the kind property of the t-value, and then you can write a custom implementation for each RTTA type. For example, for the integer type, you can use the hasInteger function and check if the value returned is 0. But now I will show you a different approach to handle this situation. I will comment this code and go to the interface section of the unit. And what I will do is annotate the validation attributes with another attribute. And in this way, the try-object validation method will do the work of test the types allowed for the attribute. First, I will create another attribute to validate the RTTA types. The attribute will be called valid types attribute. This class will contain a field to store the RTTA types, and the constructor will receive a set of valid types. Now in the constructor implementation, I will assign the valid types to the field of the class, and I will set up a custom message. In the get custom message, I will build a text with the types. I am converting the types to his string representation. And finally, in the validate function, I will compare the type of the t-value with the allowed types. Now I go to the interface section and I will annotate the mandatory validation attribute with the types allowed for this class. On this case, I will use only string types. Now, for the attribute that we have declared work, we need to modify the try-validate object function. So I will define some additional elements to store the type info. Now inside of the for loop used to iterate over the attribute of the properties, I will extract the type info of the current attribute using the getType function. Next I get the attribute for the current type. On this case is an attribute class. Then I check if the type is a validation attribute. Now I call the validate method, passing the value of the current property. Set up the custom message to be shown if the validation fails. And finally, add the message to the validation result. Now I will test the valid type attribute. So I will assign the mandatory attribute to the port property. I will go to the definition of the mandatory attribute. This validation attribute only works on string types. So how the port property is an integer, the validation must fail. I run the application and the validation fails. So it's working. Now I remove the mandatory attribute of the port property, and I annotate all the attributes with the valid type class. So far we used the RTTI attributes only to validate the values of the properties, but there is much more that you can do using attributes. For example, we can transform the content of some properties. So I will return to the testing class. and I will check the password property. Here you can see the assigned value. Now I will run the application. As you can see, the password property is stored in plain text. So I will write a special attribute to encrypt the content. First, I will define a new RTTI attribute called transform attribute. This attribute will contain the run transform method, which takes the original value of the property and converts the data using some custom code. The last parameter of the function, called duration, indicates how the transformation form. For example, for an encryption attribute, we need encrypt and decrypt the data depending in which context is used this function. So I will define a new type called T-attribute translation with two possible values, forward and backward. Now I will set up the default values in the run transform class. Next, I will define a new method to process this new kind of attribute. This method will be called try transform object, and I will take two arguments, the class instance and the direction of the transformation. I will define some RTTA object to process the attribute of the class. Then I will extract the type info of the class using the getType function. Next, I get the properties of the class, and for each property I will process the attribute. So I get the attributes of the property and check if the current attribute is a transform attribute class. Then I cast the attribute to the transform attribute type and execute the run transform method, passing the value of the property, a new t value to store the result of the transformation, and also passing the direction for the transform. If the operation returns true, we replace the value of the current property using the setValue method with the returned value. Now we need to define a new attribute to encrypt the content of the properties. I will call to this attribute encrypted attribute. Also, I will add some additional units to encrypt and encode the values of the property. In the implementation of the run transform, I will define the object to encrypt the data. This is a TPC1 cipher, which is one of the classes that use data snap to encrypt. Also, I will define a write of byte on a memory stream. And if the direction is forward, means we need to encrypt the data. So in order to encrypt the input value, we need to convert the content of the t value to an array of bytes. We perform this task using the getByte method of the t encoding class. Next, we create an instance to the cipher, passing the key used to encrypt the data. Now, using a for loop, we encrypt the content of the data array. On this point, the value is already encrypted, but we will encode the result in order to store or transmit the value without problems. So we'll use the Indy base64 encoder. And finally set the value of the output tape value to the encoded string. Now for the decryption part, we need to reverse the transformation, so we start decoding the base64 string. Then we create an instance to the cipher, passing the same key used to encrypt the data. And we iterate over the encrypted data running the decipher method of the class. Finally, we set the value of the output t value to the decrypted string. Now to test the encryption attribute, I will annotate the password property with the attribute, and I will modify the code to show the content of the tSettings class with the new values and the transformation. And I call the transform object function. And I will run the application to show the results. And now, how you can see, the password is encrypted and encoded in base64. Now I will run the opposite transformation to decrypt the password. I will change the last parameter to backward. And you can see how the password is restored to its original value.
To learn more about RTTI, you can check out Embarcadero's doc wiki at the 2 links you see there. Also on tindex.net, there's an article about enhanced RTTI, and of course you can refer to Stack Overflow. For these links and more, visit embt.co/sprint-enhanced RTTI. I'd like to tell you really quick about what's coming up next week. We have App to Store, build and publish to iOS App Store and Google Play. This skill sprint will walk you through building an app and all the way to getting it published in the various app stores for iOS and Android. This is on Tuesday, the 16th of September, at the times you see there. For more information about these skill sprints and others, check out embt.co/S sprints 15. Allow me to quickly tell you about some of the special offers we have going on right now. As part of our early bird pricing, if you purchase RAD Studio, Delphi, or C++ Builder 10 Seattle, you can save 10% on your license if you purchase by September 30th. Also, registered users of any earlier version can qualify for upgrade pricing. This is a savings of up to 45% off new user price. Update subscription is not required, but still recommended, and everyone also gets access to the free bonus pack. The free bonus pack includes the new book by Nick Hodges, More Coding in Delphi. This covers topics like writing solid code, duck typing, and multi-threaded parallel programming. You also get the new book by Marco Cantu, the Object Pascal Handbook. This is a modern language guide that covers the new features in Object Pascal, as well as some of the core runtime library. The MITA Converter Basic automates some of the conversion of a VCL application into a FireMonkey application, so you can take advantage of multi-platform application development. Also included is the VCL and FireMonkey Premium Styles Pack. This includes styles for both desktop and mobile for VCL and FireMonkey that allow you to really make your application stand out and give it that premium look and feel you want. To find out more information about the bonus pack and these special offers, visit embarcadero.com/radoffer. And now we'll have our live Q&A. Okay, it looks like a miscommunication. It means it's just David and I here answering your questions, but we're happy to do that. So if you have any questions, go ahead and put them in the Q&A section of the GoToWebinar software, and we'll get them answered for you. One of the questions that came up is if the code will be available. I believe that was his intention to give me the code, but for some reason I don't see it in the FTP folder, so I will track it down and get it from him later and make it available at the blog notes URL you see there. So it's not available there yet, but it will be available there soon. So there's a question here, can you do decisions on attributes and execute certain code if attribute is okay and other code if it is false? Yeah, you can do that. That's kind of what he was showing with the validation, is that the at runtime you can interrogate the attributes and determine whether it meets certain criteria and then have different functionality take place. And it would seem like it would be possible that a class could interrogate its own attributes, right? So a met function could say, hey, what attributes am I decorated with? So it could be a way to pass additional parameters. I'm not sure if there would be a reason to do that, but it would certainly seem like that would be possible. Lots of comments here about excitement about the new Seattle release. We're really excited about it here too. Lots of great new features in there. It's something I've been looking forward to getting the Seattle release, and it's just been a lot of great releases here. Do attributes apply only to the first following code or to all the following code? So you put an attribute on a member, it applies just to the next member. It doesn't apply to a whole bunch of members. So if you take a look at the documentation on attributes, you can find out more about that.
And Jim, for the runtime, I put a link on the wrong question to extracting attributes at runtime. There's a docwiki entry.
Oh, yep. Okay, I see that now. It's on the different one.
And also for everyone, I put a few links to other things that were also linked, like on the screen right now in the chat window. So there's some links for additional things about attributes. Also, I put the link to Rodrigo's blog, The Road to Delphi. So if you want to see other writings that he's been doing as an MVP, you can go to his blog.
He's got a number of great utilities on there, like the theme editor and style manager and stuff like that too. So lots of great resources on his blog.
He's got an RTTI Explorer as well.
Mm-hmm. Is it possible to declare annotations so some functions would do one thing if an attribute is okay or other code if not? Yeah, I would. That would be possible. That's kind of what he's shown with the validation there, is that the based on the attribute looks at the values and then it has different functionality based on what it is. Got a few suggestions here for future skill sprints. That's great. Thank you for those. This was a little bit longer skill sprint than usual. Had a lot of good details in it. I really enjoyed this one quite a bit and learned a lot from it. Let's see, the parse components and JSON automatically saves to a class to parse JSON data with the help of RTTI. But what if you have a property that you do not want to save to parse JSON? Is it possible to mark a property or variable to be skipped? William, yes, it is. I don't have the link for that right offhand, but I believe if you go look in the documentation, the docwiki, on the let me see if I can find it real quick here. On the JSON serialization, there is attributes of that, because I know there are actually attributes you can use for quite a bit of things, because it, you can change the names of things, you can change the way things are named, you can have things be skipped, you can all sorts of stuff. Let's go to the next question here. What is the usual overhead file size wise for including the RTTI information into binary, and runtime wise for doing RTTI property access? So the runtime type information is already included in the exe. I don't remember what the overhead is on it specifically, but when the new enhanced RTTI was introduced, there was a bump in the file size, but that's already there. You can force it to strip that out, but that's not recommended because it does have some unintended consequences sometimes because that RTTI information is used. As far as the performance penalty, It's not as fast as not using RTTI, but my experience has been unless you're doing like a serious amount of serialization in a tight loop and you need it to be really fast, it's not going to be a significant impact. It's not like you're going to all of a sudden have your application act like it's not running in compiled native code or something like that. It's going to be, there is a bit of performance impact, but generally speaking, unless you're running a tight loop with a lot of RTTI access in there, it's not going to be a very big impact. Here's a question. Do attributes work with generics? Trying to think. I believe they do. There's some interesting things about the type information with generics, but yeah, you can get type information on generics. I just don't remember exactly the way it comes out.
And I put a note in about RTTI size or how to control it. There's a way to specify which fields, which methods, and so on you want to keep RTTI information for.
Yes. Oh, great. Yep, that's exactly what I was thinking about. Another question here: when was RTTI introduced? RTTI was actually in the first version of Delphi, but then in the enhanced RTTI was, I think, was that added in XE or 2009, sometime around that period.
Every time I think about when something was done, I always, well, it's always been there, but I was just kidding. 2010?
2010.
2009 and prior, it was only in the published section. If I remember now, maybe I'm not remembering correctly. I think so. Robert Love did a whole code rage session. So if you search on the introduction of RTTI, so if you search for Robert Love and RTTI, but I think the fuller RTTI was 2010, and then enhanced RTTI later on. So here, there's a blog post of Robert Love's. He says it was 2009 for the published section, 2010 for the rest.
It's always it's really tricky.
Yeah, 2000.
Yeah, being internal at Embarcadero because the things are being planned so far in advance. So I hear about features way in advance, and then it's really hard to keep track of when they were released and stuff. So it's not always easy. Okay, yeah, Dave, I couldn't find anything about the attributes with generics. I would suggest writing a little sample application, pulling the type info on a generic and seeing what it looks like. Because I remember seeing it done, but it's a little bit different, and you have to be aware of generics and deal with them appropriately. Yeah, so Alf, the attributes and annotation was introduced with the enhanced RTTI, which I believe was in 2010, with Delphi 2010. Yeah, I was saying 2010. So it looks like we've gotten through all the questions. If you have other questions, go and put them in real quick. I realize we're a bit over time just because of this was being a bit longer skill sprint, but there's just so much great information in there. Actually thought about trying to trim it down, but I couldn't find anything to cut out to do justice to it because it was just, at least I thought, really a lot of valuable content in there. And I loved the way he just built this whole thing from scratch. And it's like, oh yeah, we'll just write another attribute. And I'm like, wow, now I can see all this being put together and all these pieces going together to achieve this outcome. So it was great. So thank you all for your time. Thanks for being here. And we'll look forward to seeing you. Let's see, tomorrow we have the launch webinar. Big deal. Check that out for find out all the details on what's new in Seattle. Thursday we have the Tech Partner Spotlight, and then next week we have our skill sprint with the app to store with Pavel, showing how to build an app and get it into the app stores. So certainly
tomorrow is everything new in Rad Studio Seattle with Marco, Serena, Luis Navarro, a bunch of us. Yeah, Thursday is Primoz talking about showing OmniThread library. So join us on Thursday, September 3rd. But tomorrow's the big day. We're going to show you everything that's new in Rad Studio 10 Seattle. So join us at 6 a.m., 11 a.m., or 5 p.m.
And there's a lot in Seattle. It's huge. Okay. Thanks you all for joining us. And we'll see you later. Bye.